Well, I think over time there's going to be a lot of technology evolution with the Terafab.
Finally, the first design of Terrafab has been revealed, and Elon Musk has confirmed that Terrafab, Texas will be the largest and most valuable building on Earth by far, and it will be stunningly beautiful. With a truly distinctive design, Terrafab looks more like a sci-fi city than a chip factory, and it will create over 3,000 high-quality jobs right in the heart of Texas. Elon Musk has stated that the Optimus humanoid robot and the Cybercab robotaxi will be the two products that define Tesla's future. He believes they will become the biggest products the company has ever built and ultimately even more ubiquitous than smartphones. At the core of this vision is Musk's belief that once these two technologies are fully matured, Tesla will transform from a traditional electric vehicle manufacturer into a leading AI and robotics powerhouse. That shift, he argues, could propel the company's market capitalization into the tens of trillions of dollars and reshape the global economy. However, both of these groundbreaking Tesla products are currently missing one critical piece, a key bottleneck preventing them from scaling rapidly and reaching mass production: AI chips. To overcome this final bottleneck, Elon Musk is reportedly prepared to invest $122 billion to build Terafab, a chip manufacturing facility spanning 100 million square feet, making it the largest of its kind in the world. The goal is for its production capacity to surpass that of TSMC, Intel, or any other chip manufacturer. Even SpaceX, a company that might seem to have little need for semiconductor manufacturing, is playing a major role in bringing Terafab to life. But Terafab is far more than just another chip factory. What is about to happen inside it is what could truly leave the rest of the world stunned. Forget everything you think you know about giant factories. Terafab is being envisioned on a scale so extreme that Tesla's Gigafactory Texas suddenly feels more like a roadside lemonade stand than an industrial powerhouse. Bringing together Tesla, SpaceX, xAI, and Intel, this colossal Texas venture has one staggering mission: to manufacture nearly 50 times the semiconductor output the world produces today. What makes Terafab truly different isn't just its size, it's the way it reimagines chip manufacturing. Instead of sending wafers halfway around the globe for different stages of production, the entire process happens in one place. Logic chips, high-bandwidth memory, and cutting-edge advanced packaging are all designed to move seamlessly through a single, fully integrated facility.
We expect that the Terafab is going to be around 100 million square feet, which is 10 times the size of the Tesla Gigafactory Texas.
Yeah, the numbers sound almost too outrageous to be real, but if completed as proposed, the Terafab campus would cover around 100 million square feet. Tesla's Gigafactory Texas is currently one of the world's largest buildings by floor area, spanning approximately 10 million square feet. A Terafab 10 times the size of Gigafactory Texas would have a footprint equivalent to about 1,300 FIFA standard soccer fields or the entire area of certain central districts in major cities. Construction permit applications for Terafab have already been filed in Grimes County, Texas. More recently, SpaceX paid Grimes County $10 million ahead of schedule under its Terafab tax agreement, marking a major milestone for the proposed project. Under the agreement, SpaceX is fulfilling its commitment in exchange for a full county property tax abatement for the development. In addition to the upfront payment, the company is required to pay $20 million annually over the 35-year term of the agreement. Elon Musk also reshared the news on X. According to Musk, Terafab is expected to deliver 1 terawatt of AI computing capacity per year, while producing between 100 billion and 200 billion custom AI chips annually. Terafab took a major step forward in April when Intel officially became part of the project. That move also highlighted a key reality. Building cars is one thing, but running a world-class semiconductor fab is an entirely different challenge. To bridge that gap, Tesla brought in Gary Zhang, an Intel manufacturing veteran with 17 years of experience, naming him Terafab's first officially appointed director. The choice wasn't random. Zhang previously oversaw Intel's 18A manufacturing operations, making him one of the company's most experienced chip production leaders. Bringing someone with that background directly into Terafab suggests Tesla isn't just hiring talent, it's assembling the expertise needed to compete at the highest level of semiconductor manufacturing. If that strategy pays off, Terafab could eventually gain access to Intel's next-generation 14A process technology, one of the industry's most advanced manufacturing nodes currently under development. At first glance, Elon Musk's companies seem to have almost nothing in common. Tesla builds electric vehicles. SpaceX launches rockets. xAI develops artificial intelligence. They operate in completely different industries, but behind the scenes they all depend on the exact same thing: an enormous supply of computing power. That dependence has become one of Musk's biggest challenges. Reports suggest he's now spending at least 60 hours a week focused on just two Tesla programs, Optimus and Robotaxi. Both are approaching mass production, and neither is being held back by engineering anymore. The real obstacle is much simpler. There aren't enough AI chips. Despite growing demand, Tesla's suppliers still can't produce the volume needed to keep those projects moving at full speed. Today's Tesla is far more than an electric vehicle powered by batteries and motors. Hidden beneath its exterior is a sophisticated AI system constantly interpreting the world around it. Nearly every Tesla now comes equipped with autopilot and full self-driving, powered by onboard processors that analyze live camera feeds every second. They recognize cars, pedestrians, traffic lights, lane markings, road signs, and countless other variables, all processed by Tesla's AI-5 chip, the same processor unveiled during the Terafab announcement. That computing power is already proving itself in the real world. Over the past few months, Tesla's Cybercab robo-taxis have been quietly operating on public roads across the United States with impressive results. Elon Musk says the company plans to roll out large fleets of fully autonomous vehicles before the end of the year, eliminating the need for a human driver altogether. Making that possible on a massive scale will require an enormous increase in AI chip production. And self-driving cars are only the beginning. The real computing challenge is Optimus. Unlike a vehicle that follows roads, a humanoid robot has to understand and react to an ever-changing environment in real time. It must recognize objects, maintain perfect balance, coordinate dozens of joints simultaneously, interact naturally with people, and instantly adapt to unpredictable situations, all while making thousands of decisions every second. Now look at SpaceX and xAI. At first, putting a rocket company in the same conversation as advanced AI chips might sound ridiculous. Why would a company focused on launching spacecraft need enormous amounts of computing power? You have to remember that SpaceX is no longer just a rocket company. It also operates Starlink. Elon Musk has an even bigger vision for the satellite network. He wants to evolve Starlink from a conventional satellite internet service into what could essentially become a flying supercomputer, an orbital AI data center capable of running AI reasoning directly in space. But turning that vision into reality will require something far beyond today's standard processors, a completely new class of chip unlike anything the semiconductor industry has ever produced. And we'll take a much closer look at that extraordinary chip later. And that explains why the world's biggest technology companies are racing to secure as many chips as they can from NVIDIA, TSMC, and Samsung. But Elon Musk's comments about Terafab suggest something far more alarming. He believes the entire global supply of AI chips today could satisfy only around 2% of the potential demand from Tesla and SpaceX. If that number is even remotely accurate, the problem is much bigger than a simple chip shortage. Musk isn't talking about placing larger orders or negotiating bigger supply agreements. He's pointing to a fundamental limitation in the semiconductor industry itself. The world may simply lack the manufacturing capacity needed to support the scale of computing his companies could eventually demand. And Musk's ambitions don't stop there. He has suggested that Terafab could ultimately produce roughly 1 terawatt of computing capacity every year, a number so enormous that it could redefine what we consider a semiconductor manufacturing operation. For perspective, the U.S. power grid is often estimated to operate at an average output of roughly 0.5 terawatts. So if computing becomes the new electricity of the AI age, Musk is effectively talking about creating digital horsepower on a scale that popular comparisons put at roughly twice the output of America's entire power system. And then the math gets even more extreme. If a typical AI chip draws around 250 watts, producing 1 terawatt of computing capacity could mean manufacturing close to 4 billion chips every single year. At that scale, Terafab stops looking like a project designed to support a car company. It starts looking like the foundation of an entirely new global industrial machine, one built around computing itself. Tesla knows how to build some of the world's most advanced EVs, and SpaceX knows how to build rockets capable of escaping Earth's atmosphere. But semiconductor manufacturing belongs to an entirely different universe. A cutting-edge 2-nanometer fab has almost nothing in common with an automotive assembly line. It requires ultra-clean facilities, EUV lithography machines costing hundreds of millions of dollars, atomic-level precision, and manufacturing yields so high that a tiny error can put billions of dollars at risk. A defect smaller than a speck of dust can potentially ruin an entire wafer batch. And that's where Intel brings something Elon Musk can't simply buy or accelerate with money: decades of hard-earned experience operating some of the world's most sophisticated semiconductor fabs. At the center of the Terafab vision are two major chip families, each designed around one of Musk's biggest long-term goals: The first is a new generation of AI processors, the computational brains expected to power full self-driving, robotaxi, and humanoid robots. According to the roadmap Elon Musk unveiled at the Terafab event, the AI-5 generation is expected to begin its initial ramp in 2026, followed by full-scale production in 2027. But AI-5 is only the opening move, with AI-6 and AI-7 reportedly coming in rapid succession. Terafab could unlock a massive jump in computing performance, taking Tesla's AI hardware far beyond what its current systems can deliver. But Musk's semiconductor ambitions don't end on Earth. While one family of chips is being developed to power autonomous vehicles and humanoid robots, another is being designed for a completely different environment: space. The D3 lineup is intended to become the technological backbone of Starlink, where every processor must withstand intense radiation, extreme temperature swings, and the brutal conditions of operating in a vacuum. Together, these two chip families represent two radically different engineering philosophies. One is built for split-second decisions, constant adaptation, and safe interaction with humans. The other is designed around a single priority: survival. Its job is to deliver powerful AI computing directly in orbit while continuing to operate reliably in one of the most unforgiving environments humans have ever engineered for. On Earth, Terafab's AI chips are about speed, adaptability, and real-time intelligence. In space, the D3 lineup is about endurance, bringing serious computing power beyond the atmosphere and keeping it running where failure is simply not an option. Elon Musk says Terafab could start with a production capacity of roughly 100,000 wafers per month. But that would only be the beginning. Over time, he envisions scaling the facility to an extraordinary 1 million wafers every single month. To understand just how massive that number is, put it next to the world's leading chip manufacturer. By some commonly cited comparisons, Terafab operating at full capacity would approach roughly 70% of TSMC's current manufacturing output. In other words, Musk isn't proposing another semiconductor plant. He's envisioning a manufacturing operation large enough to potentially reshape the global balance of chip production. But since its initial announcement, Terafab has faced one major question: how can Elon Musk build a world-class chip factory when neither he nor his companies has ever operated one? Advanced semiconductor manufacturing is far more complex than building batteries. A leading-edge fab requires ultra-clean facilities, EUV machines costing hundreds of millions of dollars, a sophisticated chemical supply chain, elite engineers, and atomic-level precision. One tiny defect can ruin an entire wafer batch, and even Intel and Samsung spent years refining their fabs before reaching high yields. But Tesla has faced similar skepticism before. When batteries became a major bottleneck for EV production, Tesla partnered with Panasonic, absorbed manufacturing expertise, scaled aggressively, and eventually developed its own 4680 battery technology. That strategy became a major competitive advantage. Semiconductors, however, are a completely different challenge. That's why Terafab could become one of the biggest and riskiest bets Elon Musk has ever made. Okay, so what do you think about Terafab? Is Texas really poised to welcome the world's largest chip factory? In 2020, Toyota engineers tore down a Tesla and called it a work of art. Today, Tesla's next-generation production line is keeping the entire auto industry up at night. It cuts factory floor space by 50%, saves billions of dollars in capital expenditures, and allows a vehicle to roll off the production line at an unprecedentedly low cost. This isn't just a new manufacturing process, it's a knockout blow to the traditional auto industry. Tesla has finally completed its next-generation production line for its upcoming vehicle models, and the number of workers operating around the line has been almost completely eliminated. Essentially, the entire process has become fully automated.
The thing that's most interesting about this is the production system. It's a level of production technology that is far in advance of any automotive plant on Earth.
Elon Musk has emphasized that this would be a production system with a level of manufacturing technology far beyond that of any other auto factory in the world, allowing Tesla to build vehicles faster, cheaper, and with fewer defects. So, how does this production line actually work? Which models will it produce? And why is Elon Musk willing to invest so heavily in this technology? If you could watch the Cybercab production line running at Giga Texas, you'd immediately see why Elon Musk is so confident Tesla can eventually build millions of these vehicles every year. Honestly, it barely resembles a traditional car factory. It looks more like a machine designed to print money. The Cybercab may be Tesla's simplest vehicle, with more than 50% fewer parts than a Model 3, just 2 seats, no steering wheel, no pedals, and a massive amount of open space for luggage. But the production line Tesla built for it is anything but simple. In fact, it's unlike anything the company has ever put together before. Tesla isn't just taking its existing manufacturing playbook and adapting it to a new vehicle. They're changing the game entirely. That's a major reason the Cybercab can be built at such a low cost and why Tesla believes it can eventually produce millions of them every year at Giga Texas. It also explains why production is ramping up so quickly, even though this production line has only just begun operating. There's a massive contradiction here. Tesla's simplest vehicle requires the most ambitious, complex, and unconventional production line the company has ever built. But once you look at the bigger picture, it actually makes perfect sense. Tesla is exceptionally good at building expensive cars. What it hasn't really mastered is mass-producing truly affordable vehicles. The company has barely ever built anything that costs less than $35,000. So if Tesla simply took the Model 3 production line, swapped out a few machines, and started building Cybercabs, the overall cost wouldn't drop very much, even with far fewer parts. Elon Musk has also made it clear that Tesla doesn't want a simple vehicle like the Cybercab slowly moving through hundreds of individual production stations, following the same basic assembly process the auto industry has relied on for more than a century. That approach simply isn't efficient enough. Instead, Musk says Tesla has been working toward a manufacturing system that goes far beyond anything currently used in the automotive industry, all to make one specific vehicle as efficiently and cheaply as possible. At Tesla's Texas factory, the Model Y production process starts with hundreds of individual metal panels. Those panels are stamped, transported to the welding area, and joined together to create the vehicle's body structure. From there, the body moves through the paint shop, gets dried, and then enters a final assembly line that stretches for miles. At that point, the Model Y is basically just an empty shell. As it moves down the line, workers and machines gradually add the wiring harness, air conditioning system, windows, carpeting, seats, dashboard, doors, steering wheel, braking system, and hundreds of other components. Every vehicle has to follow roughly the same sequence, with each station completing its job before the next one can take over. It's a highly organized and proven system, but there's one major problem. If even a single station runs into an issue, the disruption can ripple through the entire production line and slow everything down. A welding robot going down, a component arriving late, or even a single electrical connection that refuses to fit properly can create a bottleneck. And when you're building hundreds of thousands of vehicles every year, losing just a few seconds at each station can quickly turn into thousands of hours of wasted production time across the factory. Tesla knows this problem better than most. The company experienced what Elon Musk famously called production hell during the Model 3 ramp-up. Back then, Musk believed extreme automation could solve nearly every manufacturing problem, but reality had other plans. Tesla eventually had to remove some of the machines, put people back into parts of the production process, and completely rethink the system, all while racing against intense production pressure. Now the Cybercab gives Tesla something it rarely gets, a chance to start from scratch. Instead of sending the entire vehicle down one massive assembly line and installing every component step by step, Tesla wants to divide the Cybercab into large modules that can be built simultaneously and then brought together later. The front section could be built in one area, while the rear section is assembled somewhere else. The doors, exterior body panels, floor, battery pack, seats, and interior could each be handled on their own branches of the production system. Once those modules are finished, they would converge at a central area where everything comes together to create a complete Cybercab. You may have heard of Tesla's Unboxed process since we've covered it in some of our previous videos, but this time we're going to look much more closely at how the system actually works and why it matters so much. Because the Cybercab relies heavily on this Unboxed process. With this approach, major sections of the vehicle stay open and easily accessible throughout much of the manufacturing process. Robots and workers can reach components from multiple directions instead of being forced to work around a nearly finished vehicle. Seats can be mounted directly onto the floor before the upper body is closed, while wiring can be installed while each module is still open and easy to access. The exterior body panels don't have to be installed early in the process either, where they could get scratched, dented, or damaged during dozens of assembly steps that follow. A simple way to think about it is this. Instead of constructing an entire house from the foundation to the roof in one continuous process, you build each room separately and only bring everything together at the end. In theory, that could dramatically reduce the amount of factory floor space Tesla needs, shorten the distance components have to travel, and allow multiple manufacturing processes to happen simultaneously. And there's another major advantage. If one branch of the production system hits a problem, the other branches can keep running for a while instead of forcing the entire factory to stop immediately. But this is also exactly where the Cybercab production system becomes incredibly challenging to execute. Building each module on its own isn't the difficult part. The real challenge is making sure every module reaches the integration point at exactly the right moment, in exactly the right position, with tolerances that are measured in tiny fractions of a millimeter. That's why, even though Tesla first introduced the concept in 2023, the company didn't reach roughly 70% completion of the production line until 2026. For more than 3 years, Tesla has been working out the exact speeds, timing ratios, and millimeter-level tolerances required to keep every module moving through the system correctly. And even now, the system still isn't completely finished. That's one of the reasons Cybercab production hasn't ramped up as quickly as many people expected. At this point, it's no longer just a car manufacturing challenge. It's a massive synchronization problem involving thousands of robots, sensors, controllers, and transportation systems, all of them having to work together with the precision of a gigantic mechanical clock. Tesla is betting that once fully operational, this system can move faster than any traditional automotive assembly line. And the Cybercab was designed from day one specifically to take advantage of it. With only 2 seats, the cabin is much simpler. No steering wheel or pedals means Tesla can eliminate a large amount of mechanical hardware around the driver's position. There's no traditional instrument cluster either, allowing for a simpler dashboard. Fewer buttons, fewer wires, and fewer moving parts ultimately mean fewer steps on the production line. And to make the next generation production line more productive, Elon Musk has suggested that the company could eventually develop a 50,000-ton gigapress, far larger than the 6,000 and 9,000-ton machines already used in large-scale vehicle production. The idea immediately raises several questions. How could a machine of this enormous size be built and installed? Where could Tesla place it inside a factory? While these questions sound futuristic, Musk's vision is based on expanding technology Tesla already uses rather than completely reinventing the casting process. The biggest difference would be scale and speed. 50,000-ton gigapress could operate as part of an extremely fast, highly automated production system. Instead of relying heavily on human workers moving between different manufacturing stages, robots and machines would coordinate the entire process. Molten aluminum would be injected into a mold, allowed to solidify, removed, cooled, inspected, and prepared for the next cycle with minimal interruption. Each casting cycle could potentially take only a few seconds, making the production line resemble a high-speed electronics factory more than a traditional automobile assembly plant. The metal is heated to approximately 850 degrees Celsius in a primary furnace until it becomes completely molten. After impurities are removed, the liquid aluminum is transferred through heated pipelines into a second holding furnace. This furnace maintains the aluminum at roughly 750 to 850 degrees Celsius, ensuring that it remains ready for injection whenever the next casting cycle begins. Tesla's dual furnace approach also helps maintain material quality. The primary furnace can use natural gas to melt the aluminum, while the holding furnace can be electrically heated. A high-speed piston pushes the aluminum into the mold cavity under enormous pressure. Once inside, the metal quickly takes the shape of the mold and begins to solidify. The newly formed component can still be extremely hot, reaching nearly 400 degrees Celsius when it leaves the mold. The casting is immediately transferred to a cooling system where its temperature can drop to approximately 50 degrees Celsius. Rapid cooling helps shorten production time while also improving certain mechanical properties and reducing potential casting defects. Meanwhile, the mold is cooled to around 185 degrees Celsius and cleaned by robotic systems so that it can be used again. Any excess aluminum is trimmed from the finished component and recycled back into the melting process. Before the part is approved, Tesla can use X-ray inspection to check for hidden internal defects and verify structural integrity. However, one of the greatest engineering challenges is the enormous clamping force required during injection. Molten aluminum is forced into a sealed mold at extremely high pressure. Without sufficient force holding the mold halves together, the mold could separate and ruin the casting. A 50,000-ton press would therefore require an extraordinary clamping system. Ultimately, Tesla is also taking a completely different approach to the way the Cybercab's exterior is produced. Even the vehicle's wiring architecture is being developed around the unique requirements of this robotaxi. And there's no denying that the Cybercab's yellow exterior is designed to grab your attention. Whether you see one during the day or at night, it's almost impossible to mistake it for another vehicle. The first prototypes revealed earlier this year wore a matte yellow finish, but the production Cybercab has taken a different direction, using a much brighter, glossy yellow. Tesla isn't simply painting that yellow onto the Cybercab the way it does with vehicles like the Model Y and Model 3. The color is actually incorporated into the exterior material during the molding process itself. That's where reaction injection molding, better known as RIM, comes into play. If Tesla can make this technology work at scale, it could remove a significant portion of the conventional paint process from the Cybercab factory, and that matters more than you might think. In a traditional car factory, the paint shop is one of the biggest headaches. It's expensive to build, consumes huge amounts of energy, and requires an incredibly controlled environment. Once a welded body enters the paint process, it has to pass through a long chain of treatments. Cleaning, surface preparation, corrosion protection, primer, base coat, clear coat, and finally high-temperature curing ovens. Every stage adds time, equipment, energy consumption, and another opportunity for something to go wrong. The environment also has to be carefully controlled for airflow, filtration, dust, chemicals, and temperature. And when the finish is supposed to look perfect, even a tiny particle of dust landing on the surface at the wrong moment can be enough to send an entire panel back for rework. These are some of the new technologies being incorporated into Tesla's next-generation production line that Tesla has never done before. In the next episode, we'll discuss this line in more detail. What do you think of Tesla's innovation in car manufacturing? Is Tesla changing the automotive industry? That's all for today's deep dive into Tesla's engineering. If you enjoy exploring the technology behind the world's most advanced factories, hit that like button and subscribe. There's a lot more innovation waiting ahead.